Hello, this video is over the lesson factoring special cases, so we're continuing along those lines of factoring. Today we're going to focus on factoring perfect square trinomials and the difference of two squares. So you should remember from our multiplying binomials, we had the square of a sum, the square of a difference, and the product of a sum and a difference. So we were given those two binomials and we learned instead of foiling, there was a shortcut we could use in order to go ahead and simplify. So what we're doing today is we are kind of reversing it. So we went from, I'll say, left to right. We are now going from our simplified and putting it back into our form of binomials. All right, so perfect square trinomials. First off, how do we even know if we have a perfect square trinomial? So the first thing we're going to do is when we are given our expression, we are going to determine if the first term and the last term are perfect squares. So first off, make sure that your quadratic is written in standard form. So remember the biggest degree from your least. And so if you look here in my example, I have x squared minus 14x plus 49. So my first term is just 1x squared. Well, x squared is the term x times x. 49 can be broken down into 7 times 7. So check one. Hits the spot. Both of those are perfect squares. Now, though, we need to make sure that our second term is the product of 2 times our a term times our b term. So in this case, remember there's that 1 there with that x squared. So my a is 1 and my b is 7. So I need to make sure 2 times 1 times 7 is equal to 14. Check, it is. So I know this is a perfect square trinomial. Because of my sign here being a subtraction, I know in my sets of parentheses it's going to be x minus 7 times x minus 7, or the same thing as x minus 7 squared. So again, all we're doing is we're taking these shortcuts we learned and we're reversing them. So if you have these shortcuts, you should have them already written down handy. This would probably be a good thing to refer to as you're working on these. Now, just like when we did these before and I told you didn't have to remember the shortcuts, you could always go back and FOIL. Same thing here. You don't have to use this shortcut. You can still use one of the factoring methods we've been working on. So this is just if you enjoy shortcuts, if you're good at remembering them, then this is just another thing for you to add to your list. But again, you do not have to use this method. So let's try an example together. If we have x squared plus 10x plus 25, so the first thing, x squared, again, is the same thing as x times x, so that's a perfect square. 25 is the same thing as 5 times 5, perfect square. So check one. All right, now let's check to make sure our second term is the product of 2 times a times b. So 2, a again in this one is 1, times my b of 5. Well, 2 times 1 times 5, that is 10. So check, it hits that check mark number 2. So this is a perfect square trinomial. So I can go ahead and I break it down into x plus 5, that quantity squared. This time it is a plus because both of my signs up here are addition. All right, now let's talk about the difference of squares. So again, we have to determine, first off, does it meet the difference of squares? By looking at our first term and the c term. So basically we're looking at our a term and our c term. Maybe that's a better way of saying it. Because remember, there is no b term in these. When we FOILed these, they canceled each other out in the middle because our signs are alternating. In our binomial, there's a plus and a minus, so that middle term canceled out. A way you can always kind of quickly think to yourself, oh, maybe this is a difference of squares, if you notice there's only two terms. If there's only two terms, then a lot of times, I can't say all the time because that's not true, a lot of times then it would be a difference of squares. So if you look at my example, we have x squared minus 36 Again, x squared is x times x. 36 is 6 times 6. The rule with difference of squares is our signs in our parentheses are alternating, so I get x plus 6 times x minus 6. Let's try one together here. Factor 9x squared minus 16. All right, 9x squared. This has two kind of parts to it. So first off, 9 is a perfect square because it's 3 times 3. But there's also that x. So this monomial is the same thing as 3x times 3x. That would give us 9x squared. 16 is broken down into 4 times 4. So this meets our first check mark. Now let's go ahead and write it in our parentheses. So my a term here is 3x again plus 4, 3x minus 4. Our signs are alternating because this is a difference of squares. There is no middle term. You can again always check yourself, FOIL it out. So go ahead and multiply those first terms, those outer terms, those inner terms, those last terms, and double check yourself. Again, I can't stress this enough. You don't have to remember these shortcuts. You can always just use your factoring method, but it's just kind of a good thing to keep in mind. If you have questions, don't hesitate to reach out.